Okay, so I wanted to do a quick tutorial talking about one of the things that I recently learned on my journey to figure out how Bazel works. So the goal of this video is to create a build action with Bazel that uses a downloadable executable to write a string to a text file. So this is a pretty simple thing to do, but my goal was to figure out how to use external dependencies and how to actually just learning all sorts of things with Bazel. So I at least managed to get through this. So now I just wanted to walk through some of the steps. Hopefully someone learns something from this, or if I'm doing something wrong or something can be improved, I'd love to get some feedback. So I'm just going to start out with a completely empty folder here in Visual Studio Code. First thing that I'm going to do is I'm going to go and I'm going to add the Bazel executable into this folder. Let's see. Just going to copy it over here, and so you can see that it appears here. So now I can go and I can do a new terminal. I can run Bazel, and it's gonna tell me that I didn't do anything. I'm gonna go bazel.build. So it's just saying that like I don't have any any context about anything. So first thing that we're gonna do is we're just gonna do the simple project setup. Let me see. We go over here. Yeah. So the thing that we need is we need a workspace file. And we're not going to put anything into the workspace file for now. So if we do build now, it's going to actually succeed. And now that I did a build, you can actually see that it generated a bunch of these symbolic links. We're not going to worry about those. I'm going to do Bazel clean to get rid of those. Okay, so the workspace file basically just tells us that this is a Bazel project, so what I also want to do is I want to define a package. So I add a build file, and the build file is where I actually define all of my kind of the build steps or the build actions that are going to go into this here. So the first thing that we want to do is we're going to build a build, and that's pretty much all we need to do for the project setup. So we have a basic Bazel project here. So I can do bazel.exe build all, and it's going to build all and generate all of these files again. We'll just keep them here, but all in this case actually means nothing. So we're gonna add a custom rule to this now. There are a bunch of tutorials showing how to use all of the built-in stuff, so I wanted to focus a little bit on just making something completely from scratch. So we need one more, we've actually finished the build stuff itself, so I'm going to make one more file, and I'm going to call it my custom build rule.bzl. So this is going to be kind of the code for our custom build rule. And what we need to do here is we need to make the rule. So I'm going to call the rule my custom build with my custom rule, and this is a rule. And the only thing that this really needs to start with is implementation equals, and so we need to point this at a function. And kind of the naming convention that is given is that you just give the name the same name here, just with imp behind it. And we define this, do define, and the arguments are ctx. And we just do, well, let's do print our custom rule rocks. So now we have a custom rule defined. So all we have to do now is in our build file we do load. The load command, which means that we're going to fetch our rule. We're going to go root of the kind of root from the workspace and the package, and we're going to do my custom build rule, and we are going to load the rule that we just defined, which is called build with my custom rule. Here we go, and here we go. So now we've loaded the rule into our build file. So now we can start making build targets with the rule that we made. So let's just make one. we have to give it a name. Let's call this build me. And for now, this is all that we have to pass into it. So I'm gonna run Bazel. I can do Bazel build all, but I can also do Bazel build me. And yep, here we go. I forgot to, this needs to load the BCL file. Here we go. So you can see that now I've loaded the rule, the custom rule that I made into my build file. I've made an action, I think it's called, inside of the inside of my build file. And when I call Bazel build, I reference kind of just the package and then build me. And build me is the name that we gave it, and this name can be whatever. So we've created our custom tool. So right now the custom rule is just printing out our hard-coded message. So it would be very nice to be able to give this some configuration parameter. And the way that we do that is that here in the rule definition, we need to pass in an attribute or attributes into the function. The way that this is done, yep, here we go. It's called, we define a structure called attributes or attributes. And we're going to make a new custom attribute, which is going to be called my custom string. And this is going to be of the type attribute string, I think is correct. Here we go, and do something like this. Yeah, this is fine. Let's see if this compiles. Yep, here we go. So now our build rule has an optional parameter that we can pass in called my custom string. And the way that we can access it is that in our build configuration, instead of printing our custom rule rocks, we do ctx.at. So this is an important distinction. It's attribute here, but it's with an S here. And here I'll just reference my custom string. And I'm pretty sure this is going to, well, this is going to be fine. Okay, and then debug is printing something out, interestingly enough. So let's pass my custom string in here. We do comma, and we do this is my custom string. And now when we run this, we should, right. Yeah. So my confusion earlier is that we were just printing an empty string because nothing was being passed in. But now we've extended our rule to take in my custom string, and we say this is my custom string. It goes into the rule through the CTX object. We reference it like this, ctx attribute my custom string, and you can see here that when I do the print, the message actually comes out here. Cool. So now we're going to make this a little bit more fun. Our goal, if we take a look at the goal, is to create a build action that uses that takes this custom string that we did and writes it to disk with a custom tool. And the custom tool that we're going to be using is going to be Python. There are a bunch of kind of interesting, like really good tools to work with Python here. But for this example, I'm just going to be using Python as a custom tool, just because it's easily available. So we go into our workspace file because I can't assume that Python is installed on, or the custom kind of build tool is installed on the user's machine. So we need to download it. So in the workspace, the first thing that we do is we load the HTTP archive kind of rule. And in the workspace, we say HTTP archive. We give it a name, and the name that we're going to be giving it is downloaded Python. And we say we give it an URL. And the URL, this is just from the original, from the official kind of Python kind of download place. So I'm just going to download a zip file with a standalone Python installation. But to be able to use this, and this is actually fine to begin with, but because the Python download is not actually a Bazel kind of build file, we can a Bazel kind of build package. We have to do a little bit of an extra step just to be able to say how we use the how we can use it. And the way that we do that is we say this package is supposed to use a build file from our environment. So let's just make a new file, then let's call it my downloaded Python. Here we go. And here, what we need to do here is to start with, we're going to say that in the root of the project, in the package, we are going to reference build my downloaded Python. So this means that anyone who uses this package, downloaded Python, is going to have access to the build rules or the build actions that are going to be defined in here. And this took me a while to figure out, but this is all going to make sense in a little bit. So now we've actually defined an external package, an external code called downloaded Python, and let's just see if this runs now. Yep. So it's not doing anything right now because we're not actually referencing this package anywhere. So let's say that let's take our build step here, build with my custom rule. Let's pass the the downloaded Python into this custom rule. And the way that we do that is we go into the rule definition here, and we add another attribute, and we just call that attribute my external compiler. And that's going to be a label. And there's pretty good documentation about how the labels works. So we need to set a couple of parameters for this label. So this is the actual external build tool. So it is an executable. We need to set the this flag here that I have to be honest, I'm not 100% sure what does, but it needs to be set. And we need to say allow files equals true. Like so. So now we've defined a new property or new attribute called my external compiler. It is an executable, and it allows files. So when we go into the build file itself and where we actually define the action, now we can say that my external compiler is, we want to point at our custom Python installation. And I'm looking for the @ signal here. And that means that we're looking for a package. Package is defined here. The @ symbol signifies package. So we're going to say we're going to use this package here. And we are going to do something with it. So we need an executable from it. So if we just do python.exe and run this, we say we're going to use the downloaded Python package, and we're going to use the Python exe file from that package. So let's see what happens here. When we run this, you could see that the first thing that happens is that it actually happens so fast. Yeah, okay, so it doesn't happen again. So it did download the package. So it says, okay, so there's a dependency here on a package, and I don't have the package. The definition of that package is in the Workspace file here. So the first thing that it does, it downloads the package, and then we are referencing a file in here called python.exe. And the message that it's telling us is that python.exe is not declared in the package. There's a source file that exists, so it's telling us at this line here. So into the build file that is inside of the external package. So taking a look at the download here, we download it from this location, and here before we made a build.myDownloaded Python file. So this is what's going to be used in the downloaded package. So we go into this file here and we just add export files python.exe. And that means that the python.exe file is available outside of that package. So we've said like this is a file that someone else is going to be used. So be aware of that. So let's go back into our external our custom rules here. So now we are actually passing in an external compiler attribute into the build step. We're not actually using it. And the way to use it is we, instead of printing the string here, we do actions run. So we want to run the python.exe file that we were just passing in. So the run action here actually takes a couple of parameters. It takes outputs, and outputs is an array of files, I think. It takes an executable, and the executable is actually our Python compiler. And the way that we reference that is that it's being passed in as an attribute, but because it's an executable, we do ctx.executable dot, and then we just reference it like so, my custom compiler. And then there's a couple of other parameters that we can do, and one of the more useful ones are arguments. And for now, let's just pass in one argument, and we just do version. So let's see if we can make this a little prettier. I am terrible with formatting. Okay, here we go. So if I run this, you would assume that the executable is going to run, or at least I assumed it when I was trying to figure this out. But if I run this here, outputs may not be empty. So, okay, so this means that this build action can't just run an executable, like the executable that we have here. It has to have an output declared. So, and the way to do that is we do ctx actions, and we do declare file, and we just declare a file that's called my output.txt. And we put this output file, I have to save it into a variable, file, and take the output file, and we put it into the outputs array. Now we've said that we run this executable with this argument, and this is like a bit of a promise saying that once this is finished, this is the output file that's going to be changed. And we run this, and let's see. Yeah, that's definitely just a syntax error. Here we go. Wow, fun. Right. So so we run this here, and this works. But the thing is, it's not actually doing anything. There's no output file being generated. Here, if we go into the Bazel out binary file, and the thing is, this isn't actually being run, and this actually took me a little bit of a while to figure out. And the reason why this isn't being run is that the build step or the build rule that we have here, actually forgot to X a couple of these settings here. Here we go. We defined we've downloaded the custom tool, and we defined the build file for the custom tool. So what we're doing now is we're trying to use the custom tool. So we've passed all of the information that we need, or most of the information that we need, into the build rule itself. We've declared an output file. And we've said, okay, so we want the executable just to run the version -- version, which is just printed to the log. And the reason why nothing is happening is because the rule that we are working on does not return anything, and it is supposed to run return this this kind of structure that's called default info. It has files in it. And this is the dap set is a kind of structure for files, and yeah, here we go. So basically, what needs to happen is that we have to configure a rule to return this structure here, which contains a bunch of things. But we're just telling it that there are files coming out of it, and the output file is one of the things that that needs to go out. So now, when I run this, you can see that even if there's an error here, if we take a look at it, we do print out the version of Python, but it's complaining that my output.txt is not being created, and that's why the build is failed, because we're just saying there's an output file that's being declared. The action that we're running here is supposed to output it, but then we run the command, but then when we return, like, there's no output file that has been modified or changed. So now we actually have to write the build script itself that actually does the work. So the build script is just a Python file, and I'm just going to copy paste a little bit of Python code into it. So we just import system to take in an argument, which is a path to a file, and actually let's do this like this, and then we do another argument, which is the stuff that goes into the file. So see, just modifying the build script a little bit, so I don't have to worry too much about this. Yeah, so basically what this does is that it takes an output path, it creates a file, it writes a message into the file. Actually, easier to do it like this, I think. And then it closes the file. So this is our custom built logic. So what we need to do now is we go in here. The build rule that we made now needs to know where our Python file is. So we just add another attribute to it, and we call it my custom build script. And we just do attribute label, because we're going to be passing in a file, and we're going to do allow file. Yeah, so it's called allow single file equals true, because it's just a single file. We move this over, we go in here and we say my custom build script is at the root called main.py. So now this file is being like picked up from the environment and then being passed in as an argument into our build script. And this can be accessed because this is a file. The first argument that then needs to go into the Python compiler is going to be the so the command is going to look like this. We do python.exe, which is this one here. We're going to do main.py, and then we are going to say output file path. Yep. It'll look something like this, and then we're going to say custom string as the second argument. So it's going to look something like this. So python.exe is going to be run with the executable. We do we fetch our file here, ctx.file. So because this is allow single files, this can be accessed through the context.file, and we just say custom build script. Second argument is going to be we need to pass in the path of it. Second argument is going to be output file.path, and the third argument is going to be our custom string, which we called my custom string. That's going to ctx.add. So so if this works, what should happen is that we pass in the path to the output file. The Python main script takes it in as the output path, creates a file, dumps the stuff that goes into the file, which is the string, into the file, and then closes the file. So basically, that is going to be this is our kind of this Python file here. This is our custom build step. Or custom build script, I mean. So try this. Knows its target. Yeah, so I always forget this. We go in here. So we're missing the comma from here, and run build me. And there's probably another comma missing somewhere. Yep, here it is. Okay, so now this runs. And we can see now that if I just do Bazel.clean, it's going to get rid of everything. So our project is set up like this. So now we have a project that has a custom rule that is loaded from this file. And the custom rule is called built with my custom rule. We have an action, I think it's called build me. It takes in a string, it takes in a Python file or a custom build script, and it takes in the a reference to a file, a way to actually execute a binary file inside of an external package. The external package is defined here. We have a name, we gave it a name, we have a URL, and we have a build file. And the build file itself basically just exposes the python.exe file so that it can be used in steps. So that is being passed in here, python.exe. And then the bulk of it is we created the build rule. We created an implementation, defined a couple of attributes, string, script, and compiler with a couple of settings, defined an output file, configured the run message, and now that I run this, it creates in the output file here, and most importantly, we return the output file that can then be used in other steps. But we can take a look in here that we have a myoutputfile.txt file that is writing my custom string into it. So we can make modifications to this, and for example, this is a better string. And we run this again, and we're getting a new string here. So this kind of finishes the setup. I hope this is something. I hope someone was able to learn from this. And if there's something wrong with this or I'm making mistakes, I'm learning Bazel myself, trying to figure all of these things out. So if someone sees something that could be improved, please let me know. But other than that, I'm really excited about using this, and hopefully I can share some more stuff in the near future.